Properties of logarithms. So our objective here, we want to identify the properties, also called the rules, of logarithms. So what do we know? Well, we know what a logarithmic function is. It is any function of the form y equals log base b of x, where b, the base, is positive but not equal to 1, and x, the argument, is positive. And we know that this log function outputs an exponent. It's the name for a certain exponent. Okay, let's get into these properties or these rules of logarithms. The first three come from, are kind of the basic properties, and they come from, you can see them, I guess, when you rewrite them in their exponential form. So the log base b of 1 is equal to 0. Well, you can see that. B to the 0, anything to the 0 is 1. So if we rewrite this logarithmic expression in its exponential form, we can see why this property is true. Exponential form. Okay, so the log base b of 1 outputs the exponent 0 because anything to the 0 power gives you 1. Same thing here with number 2. The log base b of b is 1 because b, remember, the log outputs an exponent. B to the exponent of 1 just gives you back the b. Okay, so b raised to the first power is just equal to b. And finally, the log base b of the argument b to the x is x because the log outputs the exponent. So b to the x is equal to b to the x. B to the x is equal to b to the x, and that seems kind of self-explanatory. Okay, so the first three of these, a simple rewriting in their exponential form shows why they're true. If you have a 0 as an exponent, that means your answer is going to be 1 because no matter what, anything to the 0 power is 1. If your exponent is 1, well then you're going to get back to what you started with, etc. Okay, the next three, I'm not going to prove, I'm just going to share them with you. Proofs can be found for these fairly easily online, and I can certainly assist with that if you'd like for me to. So the first one is called the product property or the product rule, and what it says is the log of a product is equal to the sum of the logs of the factors. So x times y, x is a factor, y is a factor. The log of the product xy is equal to the sum of the log of x and the log of y. Let's show a couple of examples with this. Okay, we'll see with numbers. The log base 10 of 100 times 10 is the same thing as the log base 10 of 100 plus the log base 10 of 10. 100 times 10, you can split the factors up. Notice that the base always remains the same. Okay, let's do the same thing with a second example, and we'll use some letters in this case. Example 2. The log base 2 of 2 times x times y. Well, I have three factors, a 2, an x, and a y, so I'm going to have three logs. So it's equal to the log base 2 of 2, which of course is 1. 2 to the first power is 1. That comes right up from here. Plus the log base 2 of x plus the log base 2 of y. Okay, and again, as I mentioned, this is 1 plus the log base 2 of x plus the log base 2 of y. Okay, so that's the product property or the product rule. We've got two more. Give me just a moment. If we have a product property, you can probably bet we have a quotient property. And indeed we do. The log base b of a quotient, in this case x divided by y, is equal to the difference of the numerator minus the denominator, the difference of the numerator and denominator. Okay, so a product is a sum, a quotient is a difference. Okay, let's take a look at a couple of examples of this. So we'll do example 1 here for the quotient property. The log, and I'll do a base 5 of 20 divided by 3 is equal to the log, same base, the bases don't change as you've noticed, of 20 minus the log base 5 of 3. Okay, let's do kind of a funky example, example 2. The log, how about base pi? Yeah, that's a positive number, that's not 1. And we'll write my quotient here with some letters. How about x over y minus 1? That looks kind of funky. Well, this is the log of a quotient. So it's equal to the log, same base, of the numerator, which is x, minus the log base pi of denominator, which is y minus 1. So there's the quotient property or the quotient rule for you. And the final one we're going to make a lot of use of is called the power property or the power rule, which states the following. The log of the nth power of a number or an expression is equal to the n times the log of the number or the expression. In other words, we can move an exponent, we can move an argument's exponent to the front and write it like this if we need to. Okay, so we're just taking the exponent of the argument and we're moving it to the front. So let's do a couple of examples to see how that works. Example 1 here. How about the log base 3 of 9 squared? Okay, well, the 9 is the argument. We're squaring it, so we can put the 2 in front. And this is the same as 2 times the log base 3 of 9. And you'll know, of course, the log base 3 of 9, if we want to, I'll just kind of put in a bracket over here. The log base 3 of 9 is 2 because 3 squared is 9. 2 times 2, this is 2 times 2. And so that answer is 4. If you want to check this with your calculator, you can. Okay, example 2, we'll put some letters in play here. The log, and I'll do a base 8 of x plus y, and we'll raise this to a negative exponent. Okay, well, the log of an argument raised to an exponent is the power rule. We can move the exponent or the power in front. So we have negative 3 times the log base 8 of x plus y. Okay, so there you have it. We've got some of the basic properties combined, and we also included the power rule, the quotient rule, the product rule, the quotient rule, and the power rule. We're going to make use of these coming up in future videos.